look at some sigma notation problems here. We're going to do one out with a finite number. Excuse me, they're all finite numbers, but with a determined number, 4. We're only going to have 4 terms using this definition right here. So we're going to figure out what are the 4 terms, we're going to add them up, and then we're going to use these formulas up here and show that you get the same answer. So the question is, what is the first number? Well, when k equals 1, I get plus 1, which is equal to 3. K equals 2 gives me 2 squared plus 1, which is equal to 9. K equals 3 is 2 times 3 squared plus 1, which is 19. And then k equals 4 gives me 2 times 4 squared plus 1, which is equal to 33. And I already did this in my calculator. If I add them up, I get 64. So now let's rewrite this so I can use these formulas. I'm going to kind of overkill in writing this out. We don't really need to write it out this way. But I'm going to separate this into 2 different sigma expressions here. So I get 2k squared, k equals 1 to 4, plus this sum on a constant. Now we're going to do these with not 4. We're going to use that 4 later on. So I'm actually going to get rid of the 4's. And I'm just going to put n up there because we want to write our expressions in terms of n, and then we'll plug in the number 4 and we're done, and show that, hey, if we use these formulas, we get the same thing as writing out all the different terms and adding them up the slow way. This is a quicker way, obviously. It's obvious if we have a very large number of terms. With 4 numbers, this wasn't that bad. But you'll see if we had a lot of numbers, it'd be a lot better to use these formulas up here. So this is, I can rewrite this as k squared with a 2 up front from k equals 1. And this is still the same thing. So the sum on k squared is this ugly guy here. I'm going to multiply it by 2. So it's 2 times n plus 1, 2n plus 1 all over 6. Plus the sum on a constant. Well, if I have n terms and all of them are equal to 1, so if I'm going from 1 to n on 1, if k is 1, my value is 1. If k is 2, my value is 1. If k is 3, my value is 1. If k is 4, my value is 1. Well, how many 1s am I going to have here? I'm going to have n of them. So therefore, the sum on all these constants is going to be the constant, which in this case is 1, times the number of terms. So this C stands for constant. So if I add up a constant and I have n of those constants, it's just the number of terms times the constant is equal to that sum. So it's 1 times n, which in this case is n. So this is n. Let me just scroll down here and give myself a little bit more room. So I'm going to cancel these 2 with the 6 and gives me a 3, and I'm going to multiply these 2 right here. So I get n. This is 2n squared. This is 2n plus 1n is 3n plus 1 all over 3. And I'm going to get a common denominator here of 3 over 3 plus 3n over 3. And now I'm going to distribute this n and write this all over one denominator. So this is 2n cubed plus 3n squared plus n plus 3n all over 3. And combining like terms, I get 2n cubed plus 3n squared plus 3n all over 3. So now this will determine the sum on any expression, on this expression for any numbers of terms. So when I have 2k squared plus 1, if I want to find out the sum, I can just plug this in if I know how many terms we're talking about. Well, in this case, we're talking about 4. So when n equals 4, I plug this in here, I get 2, 4 cubed plus 3, 4 squared plus 3 times 4 all over 3. So I'm just making sure that that's right according to my notes. This is 4n, not 3n, sorry. So let's just change that back to a 4. Good. Okay, and if I multiply this in my calculator, let's just pretend I did this all out, I get 64. So I can do it the really slow way, which is by writing out all the different terms, all 4 terms, and get the sum. Or I can use these formulas that are at the top of the page, use these formulas, simplify them, and if I simplify them, I get a much neater expression where I can just plug in any number of terms that I have, and that'll give me the sum. When there's only 4 terms, it's not that bad. If we had 100 terms, there's no way I'm going to write out all 100 terms and then add them all up. I can just plug 100 in here and I'll be done a lot faster. So that's the purpose behind sigma notation, finding a sum of an expression for any number of terms. N number of terms in this case can be rewritten this way using the formulas that we have at the top of the page. So these formulas are obviously very important and they need to be memorized.